Okay, so I had to make a new video here. Had a little faux pas on my other one. So, talking about factoring trinomials with the a value is equal to 1. So, we'll do number 6 right here as an example to get started. So remember, when I'm talking about a value being 1, what I'm talking about is the leading coefficient. That number is equal to 1. First thing I do with these is I check all three terms. Do all three of these terms, do they have a GCF I can pull out? In a few minutes, I'll work one of those where that is the case, and I'll show you how you handle that. But this one right here, pretty quick, I figure out, no, there's not one, right? So here's the idea. We take the 64, we're going to put it up top, the 16, and make good practice here, make sure you take the sign with you. I want to list all of the factors of that multiply and give me 64. So we'll start at 1 and 64, 2 and 32. Let's see, 3. Do we have one for 3? No. Well, actually, 3. No, we don't. 4. So we take 64 divided by 4, so 4 and 16. 5, obviously, no. 6, so 64 divided by 6. So you see, give me some decimal number, right? So that's not working. 7, not going to work, but I do know 8. I do know 8 times 8 is 64. So there's my factor. So here's the way I look at this. My last number, it multiplies, give me a positive 64. That means one of two things. Either both of these numbers are positive or both of these numbers are negative. So the question is, which one is it? So here's how we kind of figure that out. The middle term, it has to add and give me a positive 16. So like, for instance, if I had like negative 3 and minus 3, that'd give me a negative 6. When they multiply, they give me a positive 9, right? So the fact that they're both, and so that's why this right here is determining whether positive or negative, if that sign's positive. So they will give me a positive 16. So go through all this. That's definitely not working. It's 2 and 32. That's 34. That's 20. But 8 and 8. Aha. That is 16. So b plus 8. B plus 8. That's my answer. Now you probably noticed real quick, and if you think back to your Algebra 1 stuff a couple years ago, when you see two of these things right here that are literally a carbon copy of each other, you can simplify that by writing it as quantity b plus 8 squared. So would I accept this? Yes. I might look at you and go, really? Because this is really the more correct thing. But they're both correct in total. So there you go. There's your first one. Let's look at another one here. Let me find one that's going to work here. So number 9. Number 9 will work. Well, no, I don't want to do that one. I'm gonna do number 12 right here because different signs and all that stuff. So actually, I'll probably do number 11 and 12. Let me do 11 first. So 11, there's no GCF between them. So now I look at it and go, okay, negative 56, negative 1. So 56, 1 and 56, 2 and 28. Yeah, 28. Let's see, 56, 3, nothing. 56, 4, 4 and 14. Okay, so we got 4 and 14. 5 obviously is not working. 6. So think about 6. Let's see. 6 and 8 is 48. 8 and 7. Yeah, 8 and 7. Because 8 and 6 is 48. 48, 7, 56. Yep. So 56. Is there any more that I can think of? 7, 8, 8, 7. That's pretty much it. All right, so multiplies to give me a negative 56. Now, what that tells me is that the signs are going to be different this time because they have to multiply and give me a negative number. So the rules about our signs, that's what it tells us. So here's a cool little thing right here. So I know the signs are different because of that. The fact that it's a negative, that tells me that the larger number is going to be the negative number. So now I just go through the list and I go, okay, which one gives me a negative 1? That clearly is not going to do it. Neither is this one. This one's not. That's going to be a negative 10 there. But, oh my goodness, I'm so silly. I'm sorry, because I put it backwards, didn't I? So 7 and 8. Yeah, I like to have them kind of in order there. So that's actually the negative. My apologies. I'm sure you've already written that down and went, it's late in the afternoon. My brain's shutting down. So 7 minus 8 is negative 1, right? So 7 and a negative 8. So we have n plus 7 times n minus 8. And you are done. Okay? So the more you do these, the better you get at them. So you'll learn you'll kind of catch on pretty quick. Just look at the signs, kind of what's going to have to take place. So there's that. Now let me go in and let me do a problem that has a GCF that could be pulled out. So I'm going to do a smaller one here. I'm going to do number 16, and I'll leave the more challenging ones to you. So Merry Christmas. All right, 5, 10, and 20. 5, right? So I'm going to pull it out, and I'm going to factor that. I'm going to rewrite it. It's n squared plus 2n plus 4. Okay, so there, pull the GCF out, and I'm going to change my color here now. All right, so that 5, I'm not throwing it away. I'm not just going to erase it. I'm just not going to deal with it until later. So I'm only looking at this, so do not get bumfuzzled by this sitting outside of here. This is what I care about. So this is what I'm going to actually factor. So factors of 4, that should be hard. 1 and 4, 2 and 2. Okay, so 1 and 4, 2 and 2. So do I have factors here that will actually work? So it doesn't look like it, does it? Kind of hit a roadblock. So sometimes it is possible that when you pull the GCF out, I kind of picked a bad one for you, didn't I? That's okay, though. You need to see this one. This actually is factored out all the way because it can't be broken down anymore. But the process is still here, right? So even though this one didn't quite work out like I liked it, that's not a big deal. We're not worried about that. We don't panic and stuff like this. So you factored the GCF out, which was the 5. You look at the trinomial, and you go, okay, let's see if we can factor this out. Now, it just so happens this time, couldn't factor it out. Okay, nope, not a big deal. This is okay. So let's do another one that will actually work. Fingers crossed, right? Let's see here. I bet if you're slick, you're looking at these trying to get the answers right, but I ain't gonna hold it still long enough. Ha 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 ha. Let's see. Where's that? There we go. That'll work. Let's do number 17. So number 17, the GCF is 2. So k squared plus 11k plus 30. Okay, so now we look inside of here, just like what we did before, but this time, this is going to work, okay? So don't freak. So 30 and 11. So factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Yeah. Okay, so multiplies and gives me 30, adds and gives me 11. That's pretty easy to see is 5 and 6, right? Because that's 11, that's 30 when you multiply. All right, so when I actually write my problem, or I'm sorry, my 2 binomials, my brain's just shutting down today. So k plus 5 and k plus 6. The 2 that I pulled out to the left earlier, I'm just going to set it right outside of here. Do not redistribute it. That's a no-no. Factoring, remember, is the reverse of distributing. So don't Don't re-enter that into the problem. You just leave it like that. That's it. Um, so you looked at one where the factor in the trinomial thing kind of failed other than pulling GCF out. You've seen one where it's working. Now, let me show you one real quickly that won't work, period. Well, maybe I shouldn't say period because actually it will. It's just going to be a non-real number. But for the time being, we'll say it's not factorable for this at this time. So let's take a look at number 8 here. So 24 and negative 4, okay? So list all my factors of 24. Okay, so 1 and 24, 2 and 12, 3 and 8, 4 and 6. That's pretty much it. Okay, so they multiply and give me a positive 24. That either means both are positive or both are negative, right? We've already discussed that. That's a negative. The middle number is negative, so I know that all numbers are negative. So these have to add to give me a negative 4. So let's see which ones are going to work. And you probably already figured out that none of them are working. So this is a situation where what we say it is not factorable. Or is it? A little cliffhanger. So to kind of give you a little inkling, this thing is like not touching the x-axis is what's happening. It's kind of floating up there at the top. But that's another discussion for another time. But so is it possible to run across some of those? Sure. And the further we go in our study of quadratics, we're going to see more stuff like that. We're going to have to know how to handle that. And I'm going to show that to you when we get there. So, real quickly, let me turn my little... there we go. So, one other thing I'm going to point out to y'all. Let me make sure this is in the picture. Yes, indeed. So, guys, I'm just going to reiterate something here. I've been saying, and you've seen me point to this thing 100 times, is this list. Guys, a lot of the problems that I see, not just I'm talking about all my classes over the years of me teaching, is it boils down to these things here. If you can get this stuff right, math becomes so much easier. People miss basic order of operations, the signs, the timing thing when we start doing ACT practice stuff and all. Combining like terms, distributed property. This right here, this is hands down. If I could sum all of this into one, it'd be number 6. Paying attention to details. The reason you miss a lot of the stuff you do, and I'm talking about like not just y'all, I'm talking about all students. The reason you miss things is because you don't pay attention to details. Guys, these are things that I am unable to help you with. These are things that, like, coming into this class, you should be able to do. So if you're lacking in that area, this is the time to start getting better, okay? So as you're working on your assignments today, take time. Hey, if you don't get done with every problem, okay, but at least the ones you do get done, you know for dang sure they're right. Okay, so I'm going to leave you with that. I'm going to go get some stuff prepped for tomorrow, and y'all have a good day.